Hello friends, this is Durga from IT University. As part of CCA, Spark and Hadoop Developer, at this time I'm talking about the second module, Transform, Stage and Store. And so far I have covered load data from HDFS and storing results back to HDFS. And also I have covered how to submit the Spark programs, Python-based Spark applications using Spark submit command. And now we are going to talk the more advanced topics like joining, calculating the aggregates, filtering data, etc. But before getting into that, I would like to get into the basics of the Spark programming by explaining what the transformations are, what the actions are, and also I will be demonstrating how to write word count program by using both uh, uh, transformations as well as actions to get the word count, and then we will see in the details about how to join the data, how to calculate the uh, aggregate statistics, and many more. So I'm quickly getting into the Cloudera VM, and I'm already in Pyspark and connecting to 1.2.1 Spark. And then before actually writing the Spark program, let's cook up some data for the word count. So I am creating a file called wordcount.txt, and here I am saying hello world, how are you? I am fine, and how about you? Let us write the word count program using Pyspark, Python on Spark, and save it, exit, and then Hadoop fs minus put word count.txt user Cloudera. So I am saving that word count.txt file into user Cloudera. Now I am getting into the Pyspark terminal or command line interface, and here you can read the data by using sc.text file. Sc stands for Spark context, and by passing the location of the file user Cloudera word count in this case .txt and enter, and now the data is nothing but RDD, which stands for resilient datasets, resilient distributed datasets, and we'll be applying transformations as well as actions on top of that to get the word count. Before getting into the transformations and the actions, first we need to understand what the resilient dataset is. For that you can go to this one and search for RDD. We are in the official Spark 1.2.1 documentation. You can see you can see the definition of the RDD. RDD is nothing but a fault tolerant collection of elements that can be operated on in parallel. So if you have a very large file, and if you have a large Spark cluster with gigabytes of memory, and then what will happen is that a large file will be divided into fault tolerant collection of elements that can be operated in parallel. So depending upon the number of tasks that will try to process the data, and that the file will be divided into those many RDDs. Each one will be operated in memory by Spark, and they will be operated in parallel. So there are two ways to create. One is by parallelizing an existing collection in your driver program. So you can use something called parallelize function like this, and then you can actually create RDDs by using multiple threads, or you can directly refer the dataset from an external storage system and assign it to a variable like data, which we have done here. It will become RDD, and it can be there can be many RDDs if the data file is large, if the file size is large enough. So that is about RDD. It stands for Resilient Distributed Datasets, and it is fault-tolerant collection of elements that can be operated in parallel. So once you have RDD, you can apply something called transformations. So transformations is the one which will actually manipulate the data. And the examples of transformations, if you scroll down here, you can see that list of transformations. You have map, filter will be covered later, flatMap, map partitions. These three are important transformations which you need to understand. First we'll start with map and flatMap for the word count program, and down the line we will see the map partitions also. And the sample is to get the sample of the data set. So if you want to just get some percentage of data to play with it, you can use sample function. And if you want to perform set operations, you can use union or intersection. If you are familiar with sets, they are pretty straightforward to understand. And then you have distinct to get the distinct values. Group by, if you want to group by the data, group by a particular key and perform certain actions on the data, you can use group by key. And reduce by key is if you want to reduce and get some aggregations around that, you will use reduce by key. We will see that as part of the word count program, and also the other topics that are relevant for the certification. Word count might not be directly relevant for the certification, but it will help you to understand the implementation of end-to-end flow for a Spark application. And then sort by key is to sort the data, we will see later. Join is to join the dataset, we will see that later. And there are many more. I will not be covering everything as part of this, but I will try to touch base all the important transformations that are relevant for the certification syllabus, like joining the dataset, calculating the aggregates, filtering the data, etc. But make sure you understand, at least you have basic understanding of almost all the transformations as well as the actions. Actions is the ones which will actually perform or make the program execute for you. So for example, reduce is an action where it will actually aggregate the elements of the data set to get the row count, etc. We can use reduce, and also count to get the row count. Reduce, you can also get something like overall sum or average, etc. Collect is to collect the collection, and then you can take the actions such as printing out of the collection. Whenever you see these actions, the programs will start executing with the actions, like collect. Take is if you want to get only 5 records or 10 records irrespective of the number of records in the table. For example, if you are using MySQL, you might use select star from a table name, limit 100 if you just want to see 100 records. Similarly, if you are using Oracle, you will see row num less than or equal to 100. Take works like that. If you just want to display n number of records, you can use take for that. And then we have already seen the actions save as text file, save as sequence file. Save as object file is only applicable for Java and Scala. Count by key, if you want to get the count by key, you can apply the action directly. So when it comes to transformations, the program will not be executed immediately, because Spark applications follow lazy evaluation. Whether you use Scala or Python, it doesn't matter. Both use lazy evaluation, and only when you apply these actions, the program will start execution. And actions also take certain perform certain tasks on the input data while applying that action. So now let's go ahead and start writing the word count program. Okay, so we already assigned the data to RDD called data here. So you can actually say data map. So data dot map, we have to apply the map function. So to apply the so to perform, so if you think about word count, there are two things which you need to do. One is that one is first you have to apply the transformation. When you say transformation, you have to reformat the input in a way wherein we can actually get the word count down the line. For example, in this file, you have 3 lines and each line have multiple words. So to get the word count, you have to assign a number 1 for each and every word you have. Okay, so you have to read one line at a time, and then you have to apply transformations in such a way that each word is assigned a numeric 1 as value and word as key, so that we can actually perform aggregation down the line when you try to use map reduce approach using any of the big data technologies. So for that, if you go back to the documentation, you can use flatMap and map function. You cannot use map function alone, you have to do flatMap first. So for that, you need to understand what the flatMap is. So let us do this. I'm going here, I'm creating data flatMap equal to data dot flatMap, and then I have to create a lambda function x dot split space and hit enter. Now if you want to view how it look like, how this new, every time you apply these transformations, it will create a new RDD for it. And if you want to see how it looks like, you can run this for I in data flat map dot collect. If you are dealing with very large data set, I will recommend you to use take of 5. Again, this is the action. Collect and take 5 are action. Take of 5 will only give 5 records rather than returning everything. In this case, we are dealing with only a small data set, so I am using collect itself, and then print of 5 and hit enter and enter. You can see that each word is flattened, but it is not assigning 1 with this. So if you try to use map directly instead of flat map like this, data map equal to data dot map lambda x comma 1 sorry, it should be space, because each line we are getting, flat map will automatically flatten, but map does not. Map only get 1 record from the RDD and try to apply the transformation on that. So if you want to get 1 for each word, you have to split it and then you have to apply, but even this one will not work. Let's see. Okay, for in data map dot collect print of I and hit enter. You can see that for each array it is assigning value 1, which is not correct. so you cannot directly apply map on top of the input data here. You have to flatten and then apply map. If you want to do some task on the line itself, then you can use map directly. But if you want to do programs like word count wherein each line has to be flattened into multiple rows, then you have to first do the flat map like the way we have done here, and the output of the flat map will look like this. Now we have to apply another transformation on this by converting each of this line into a tuple of key value pair, where the key will be the word and value will be the 1 for each of the word. So what you have to do is you have to create data map on top of data flat map, and then your lambda function is just x comma 1. X will be whatever the input is, each line of your input, and 1 will be a hard-coded value 1 for each of the lines, and hit enter. Now if you do for I in data map dot collect and then print I, you can see that each word got a value 1 with it. Now we have applied the transformations. We can actually apply aggregation based transformations also. For example, in this case, if you go to the transformation, you have reduceByKey and Aggregate-by-Key. They are aggregation based transformations. Okay, so we have to apply these things to get the count or sum of each word, how many times each word is repeating. That is the requirement for the word count. ReduceByKey is the simplest form of it, so we'll use reduceByKey. So word count equal to data map dot reduceByKey. So in this case, it will take two. You have to create the lambda function, and it will take two variables. One is the current record and the other one is the next record. So it will try to add current record and next record, and then store it in memory, and then when it goes to the next record, it will fetch the next one and add the output to it. So for that you have to create two lambda function with two parameters x and y, and you have to define the functionality for it, which is x plus y in this case, and then hit enter. Now you can say for I in word count dot collect. When we say reduceByKey, if there are multiple keys with the same name, as in this case you have how is one word where it has repeated twice. So for each word that is repeated, it will group, and then it will apply this lambda function to add the values. X and y will be the values for each of the keys. Collect and then print of I and hit enter. You can see for each and every word you are seeing the count: and1, am1, r1, world1, find1, how2, because how repeated twice, etc. So this is how you can actually get the word count by applying three transformations: flatMap, map, and reduceByKey. You can apply Aggregate-by-Key also in some cases where you have to apply something called custom combiner. You can use Aggregate-by-Key. We will see that later, but as of now we have seen flatMap and map to do the transformation to convert each line in your input file into a key value tuples of your word and a hard-coded value 1, and then we have performed another aggregation based transformation, which is reduceByKey, to reduce for each key which is repeated, and then get the count of that key. And then we have also seen the collect function to collect function, which is an action to fetch the results and print on the standard out. If you just want to get 10 records rather than everything, you can just say take 10 colon and then print I and hit enter, and now it shows only 10 records here. So this is how you can actually write end-to-end Python based Spark application. In this case we have accomplished word count, very straightforward, but you need to understand all the phases that are involved internally, which I have not covered in this video. I have just covered the program. In the next video I will cover how the map function and reduce function work together, along with the additional component called shuffling between by doing the whiteboard, which will make it more clearer to you. But in this video I have covered the word count program itself, and the word count program is not available in the GitHub account yet, but I will put that before the joining the disparate datasets very soon. That being said, I hope you are enjoying the content on my channel. If you like this video, please click on the like button. If you have any feedback, please use the comment section of the video. If you want to ask any technical question related to word count program, you can use Stack Overflow by tagging it appropriately, Spark and Pyspark in this case. And if you want to be part of the discussions for any certification, you can be part of IT Varsity Hadoop Certifications group. And if you want to be part of Spark related discussions, you can be part of IT Varsity Apache Spark. And if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye.